So in this topology, guys, we have like 3 switches and they are connected with each other. And our task, our main objective is basically to create a VTP. And VLAN trunking protocol is going to help us in creating those VLANs and communicate with them. And then we will create a VTP server, VTP client, and we will see the difference between VTP client and VTP basically a transparent mode. If you open the lab, which is 2112144, you will find that the topology have already configured with sub interfaces, with virtual interfaces in the switches, with IP addresses, and now I need to follow the steps. Do you want me to show you the lab, the actual lab as well, or you have a copy of it? This lab for Packet Tracer configure VLANs, VTP, and DTP. Do you have a copy of this? It's in the classroom page. Okay, so the first thing I will do is basically all I need to do is now I want to configure a trunk between those switches. So to configure this trunk, we need to configure a VTP server, and then we need to do a VTP client in the switches that we believe they are a client, not a server. And we have to observe the behavior of the VTP on this topology and to maintain and to guarantee that there is end-to-end connectivity in the same VLAN. Now, the first thing I will do, I will go to S1 and I will go to CLI mode and I will just do a simple show. Now, I want to give a brief or to take a brief about the whole VLAN, so I will do show VLAN a brief. Now the brief comes back to me and it said, okay, all these interfaces are basically in VLAN 1. We have VLAN 99 management and we have VLAN 999 and we have other VLANs configured in this network. Now we want to continue and basically repeat the same step for other switches. Go back to the CLI, press EN for enable, and then show VLAN brief. The same, you see that the switch 2 as well, we have VLAN 1, VLAN 99, VLAN 999, 1002, 1003, 1004, and 1005. Now the most important step that we are going to do in the next one, which is configuring the VTP. So we have to go back to S1. This is S1, and what I want to do now, you see those interfaces? You see that S1 is connected to S2 by the gigabyte interface 01 and 01 from this side. Also with S3, this is S3 guys, it's also connecting 02 with 02. Now to enable trunking, what we need to do is to change the switch port mode in those switches to dynamic desirable. So we have to go to interface G01 in S1 and S2 and we change them. So now from S1 I just do config T and then I will access the interface, which is interface G01, and from interface 01, as I showed you last week in the presentation, in chapter 2 presentation, we have to put this command, which is switch port mode dynamic, and this is going to be desirable. You will see now that the line protocol on this interface, the VLAN 99, changes status to up, and there is some negotiation happening between switch 1 and the switch 2. We will do the same in S2. We have to do the same for S2. So we will go to S2, and then we repeat the same step. So we'll do config T interface, and the interface I want is G01, and then I will do switch port, and then the mode of this switch port is going to be dynamic and desirable. Now if you go back, you will notice that S1 is connected to S2, and this connection we need to configure it as a trunk. To do so, we do those two steps. So we go back to S1, okay? Now we'll exit that, exit the sub interface, and just do now G02. And as long as I need a static trunk, all I need to do is to make a switch port mode a trunk. So now I'm saying the connection between S1 and S3 is a static trunk. It's not a dynamic desirable. So I enforce the trunking protocol to be applied in this connection. I will repeat the same in S3. So this is the CLI for S3, enable, and then config T, and then I will do interface G02, and in this interface I do the same. Switch port mode a trunk. Exit this, and now go back to the topology to observe the behavior. You will see now there is like an ambient line here with S3 because the trunk protocol is negotiating with its neighbor in order to start the protocol. Now how we can verify this? Okay, to verify this there is so many ways and so many show commands. So from S1 all I need to do is do show interface a brief or trunk. So I want to do show interface trunk, and the do here I feel so lazy to exit the config mode and come back to it because maybe I need to fix something. Now notice what we have now when we just put show interface trunk. It said port 01 is in desirable mode and the encapsulation is 802.1Q, which is the trunking protocol, and it's in a status trunking. Now, what is the name of the native VLAN that this trunk belongs to? 1. So, in the second interface, which is the G02, we have the trunk configured in mode on, and the reason for this on that I make a static trunk, not a dynamic one. Same protocol, status is a trunking, and we have also access the native VLAN 1. Now we want to make this not VLAN 1 because the VLAN 1 is the default one, so we will make it something else. But what we need to understand that the native VLAN in this configuration is VLAN 1, and this is a typical exam question. I just give you the output of show interface trunk, and I will ask you, for example, which mode is used, what is the status of the port, and which VLAN or what is the number of the native VLAN in this switch. The second step, we want now to configure VLAN 999 as the native VLAN for trunk link on S1. So S1 should use VLAN 999 instead of VLAN 1. To do so, we have to exit this sub interface and we want to make access the range, because now I make G01 and G02 both belongs to the VLAN 999. So I will just do interface, and this going to be range, and G01 to G22 basically. So this is the interface range I want to make, and now switch port mode a trunk, and this going to be native switch port mode switch port trunk, sorry, there is no mode, switch port trunk, and this trunk is going to be native VLAN, and the VLAN number is 999. Once you will enter this command, you will see that now the CDP is trying to find there is a mismatch between the native VLAN in both switches, and between S1 and S2, between S1 and S3, and you will see the output that there is like some BPDU message has been exchanged between VLAN 1 and VLAN 999, and there is some mismatch. We will fix that in very short time when we go back to S2 or S3 and we make the trunk port in those belongs to the same VLAN. This issue will be resolved. So I go to S2. So this is S2. I exit the subconfiguration. I access the interface range, which is G01 to 2, and I said switch port a trunk, and this is going to be native VLAN and 999. This is in S3, S2. While the CDP start to negotiate with its neighbor, and we will see if the VLAN has any issue or any mismatch or the protocol is up or down, we will go quickly to S3 and we will do the same. We will exit the sub-interface and we will do interface range. Okay, I have to be on the config mode, guys, so I have to go back, config T, interface range, and this is going to be G01 to 2, and I will do the same command, which is switch port trunk and native and VLAN, and the number of the VLAN is 999. And you'll see now, like the spanning tree protocol is unblocking this port because there is no mismatch. There is a trunking protocol and there is negotiation happening between G02 and G02 in switch 1 and so on. Now we want to configure and to verify that everything is working fine in those switches. So what I will do, I just go to S1 and I repeat again my magic command, which is the do show VLAN show interface trunk. You will see now it is undesirable, it is the encapsulation, it's in a trunking, and the native VLAN now becomes to be 999. In part 2 of this tutorial, guys, we want to do a simple configuration for the VTP. Now in VTP, we have to do two major things. First, we have to configure a server and we have to configure a client. And in order for those servers and the client, which is a simple client-server model, we have to basically specify a domain. So the client would know what is the domain, and there is a password they can exchange so they can communicate with each other. To do this, we want to go now to S1 and make it as a VTP server. So I will exit this configuration and then I will do config T and then I will start again. So the VTP mode, and this is going to be server. Now VTP domain is going to be CCNA, and the VTP password is basically Cisco. This is what we did in VTP in S1. To verify that the VTP configuration has been applied to this server, you can just simply say do show VTP status. There is no show, so I go back, fix this. So you will see now that the VTP version, the configuration revision, which is something really important to take notice of, and keep trace of this number every time you add or you change a VTP domain or a VTP client or a VTP server, as we are going to demonstrate in the second part of this lab. Also, the VTP give you the ability to show the VTP password. So if you want just to show the password, you can just simply say do show VTP password, and it will give you the password as a plain text. If you want to encrypt it, remember the first primary step we did in CCNA when we just put a simple command to encrypt all passwords on the OCI device. Now we will do the same for S2. Now in S2 we want to add this switch as a client for the VTP server. So I will exit the sub range and I will do VTP, and VTP is going to be mode, and in this case switch 2 is going to be a client for the server S1. So this is going to be a client. Again, the VTP domain is CCNA, and the password is going to be the most complicated secured password on earth, which is Cisco. At this stage, you will find that both are joined by the VTP. Once you put and configure this VTP command in S2 as a client, you'll see now it's copying the same VTP configuration from S1, and this is the domain, and this is the domain name, and this is the mode of this device. Now in S3, we want to do something different. We are not going to configure this VTP as a client. We are going to configure it to be in a transparent mode. And I will explain now what we mean by a transparent mode by this simple experiment. So in S3, guys, I will do a simple configuration, VTP mode, and this is going to be transparent with capital letter, and the domain is going to be CCNA, and the password, same configuration, guys. The only major difference is basically the mode. Instead of server or client, we have something called transparent. Now, when you say from this server, from this switch, when you do show VTP status, you will see that it's got the same status of the VTP. Now, let me tell you something really important about this. When you configure a switch as a transparent mode, this means the VLAN configuration are saved in the NVRAM, but they are not advertised to the neighbor, because this is a transparent mode, which means he's not active or passive in the advertisement and negotiation with the other servers and clients in the domain. Okay? So this is the only difference. So it means all switches by default are configured as a VTP server, but without a domain. So there is no advertisement. This is the only difference between a client and server. When you have a switch as a VTP server, this switch will take everything it has at the VLAN.dat and start to broadcast it and advertise it to every single VTP client found on the domain. But with the transparent means, I'm listening, but I'm not broadcasting. I'm not saying anything. I am okay. I am neutral with all the advertisement and everything happening in the domain, but I'm not participating. So it's possible to have a VTP mode transparent, which means it's a server, but it's not an active server. There is so many applications for how you can employ VTP transparent. Let's say you don't want to configure a domain. Let's say you don't really have so many switches to join the domain. And there is so many implications of that, as we are going to see now. Maybe that switch specifically have so many VLANs and you don't want to share with the rest of the switches on the domain. So there is so many scenarios where you need VTP mode transparent. Now we will go back to S1 and we will create more VLANs. To do so, I create VLAN 10 and I will call it red. Then I will create VLAN 20 and I will call it blue. Then I will create VLAN 30 and I will call it yellow. This is now in S1 and you'll see the difference and how easy now with VTP mode, how VLANs are much easier to configure in a switched network. Now, if you just want to verify what happened in this network, all you need to do is to show VLAN. So once you do show VLAN brief, you will find that there is VLAN 10, VLAN 20, and VLAN 30. Now this is the trick. Go back to S2, guys, and just follow this step carefully. Give me your attention now. Do show VTP status. You will see that the VLAN configuration has been, configuration revision has been changed to 6. It was 0, which means there were major changes happening on this network. Okay? Now look how many existing VLAN we found in this. We find 10. There were, before we added 3 VLANs, 7. Now if you go back to S3 and you do the same, you just basically show the VTP status, you will find the VTP status is not changed because this switch is configured with mode transparent, which means don't annoy me about everything happening on this network. I am happy with my configuration. I'm not sharing them with you, and don't share your configuration with me. I am transparent. I am in neutral. Okay? Now, if we want to make those configurations applied as well to switch number 3, all we need to do to change the mode of this switch from transparent into client. So let us do that. We'll do VTP mode, and this basically is going to be a client. Now we will wait for a few seconds and we will do the same command again. Now you will see that once this switch has been changed to a client mode, all the configuration revision has been changed. The number of existing VLANs is 10 at this stage, so this switch has copied and received the advertisement from switch 1 and the switch 2, so it knows what's happening on this VTP domain. Okay, now the last step is basically we want to access. I will quickly show you how in one switch how you can do access port and you configure a specific port to be joining a VLAN. So in a switch 2 in S2, all I need to do is interface. He's asking me to make the fast Ethernet port 1 up to 8 to access VLAN 10. So I will do just interfaces range F01-8, and this is going to be switch port mode. I need to change the mode to access first, guys, and then I will do switch port access VLAN, and he is asking me to make it accessing VLAN 10. From same switch, I want to make F09 to 16 to access VLAN 20. So I should basically change this to access, and this is going to be VLAN 20. Exit this, go back to the second portion of interfaces, and he's asking me to make 17 up to 24 in access mode, guys, mode access, and then switch port access VLAN 30. I have to repeat the same step, and you see that there is now an ambient, so we have to repeat the same step in S3. So F0 interface range, and this is going to be F0 1-8, and switch port mode access, and then switch port access VLAN, and this is should be VLAN 10. Then I exit this one, and then I will do interface range F0 9 to 16, and switch port mode access, and then switch port access VLAN, and this is A20. Finally, I do interface range, and this is F0 17 to 24, and this is the switch port mode access, and then switch port access VLAN, and this is 30. The magic command copy run start with do, so we save those configuration, and by this we completed this tutorial. So in this tutorial we reviewed how we can configure trunk and VTP and DTP client server transparent, and we test the configuration. You will be asked to do the same in the lab today. Thank you, guys.